Hi, Science 10s. This is lesson CA9 in your Chem A note package. So CA9, and it's called Polyatomic Ions and Compounds. So hopefully you've been through every other lesson that we have posted, written all your notes, done all of your worksheets. This is one of the last naming ones. We'll do some acid-base nomenclature in CA10, which I believe is in your student notes package as well. So looking through, so flip to that, make sure you have your periodic table. This is another one that's important to be peeking at your periodic table. So key reminders. These are things that we've already looked at with the previous ones. So oh my goodness, what a mess I'm making. Um, so some of the key reminders. So the net, which is kind of a fancy way of saying overall charge of any ionic compound, is neutral or zero. So that's saying your number of positive charges is equal to your number of negative charges. So overall, it has a net charge of zero. So when we've been writing it, so the cation, which is the positive, I don't know why, this is an Alana thing again, writing plus the positive. So the cation is written first, and the anion, which is our negative, is written second. That still is true in this. But now what we're going to deal with is polyatomic ions. So the word poly means many, atomic meaning atoms. So a polyatomic ion is an ion that contains many atoms. And so in your periodic table, I just need to grab mine. In your periodic table, it's kind of on the left-hand side up above the periodic table. So it says table of polyatomic ions. So again, polyatomic meaning it has many atoms. And again, when we're talking about ions, that means it has a positive or negative charge. So it's found in the box in the middle of your periodic table on kind of the left page of it. So polyatomic ions are treated as a single unit. So they travel together. So a single unit or one ion that has an overall positive or negative charge. Or it can be more than one positive or more than one negative, but they travel together. So they're treated as a single unit, even though they're made up of many atoms. So polyatomic ions can either be cations or anions, depending on their charges. So looking in the periodic table, up in that polyatomic ions, you see somewhere it says SO4 with a 2 minus. So what that's saying is it's made up of a polyatomic, many atoms, so it's made up of 1 sulfur, it's made up of 4 oxygen, and it has an overall net charge of 2 minus. But these stick together, they travel together. This is all one thing that sticks together. And it has an overall net charge of 2 negative. So you don't need to start looking at, oh, sulfur forms these ions, oxygen forms these ions, its overall charge would be way bigger than that. No, there's sharing of electrons within this polyatomic to give it an overall charge of 2 negative. So that one, SO4 with a 2 minus, sometimes it's helpful even to put little brackets around that because you need to be very clear what's a subscript and what is a superscript. So a subscript tells us the relative amount of a particular atom. A superscript, so high, up and small, tells us the charge. So that one, SO4 with a 2 minus charge, is actually the polyatomic ion sulfate. NH4 with a 1 plus. So again, be so careful when you're writing something like this out. NH4 with a 1 positive. This is not NH4 positive. That 4 is a subscript, meaning there's 4 hydrogen and there is 1 nitrogen. So that positive, if you need to, if it stresses you out, change it to +1. Usually you'll just see it as a plus, but if you need to write +1, because then you don't start thinking it's 4 positive, that's okay as well. So that one, if you look there, it's actually ammonium. And ammonium is the only polyatomic cation. Oh, I wrote an I there that doesn't need to be there. Only polyatomic cation. So it's the only polyatomic that has a positive charge. Up in that top corner, you see everything else other than ammonium has a negative charge. So either 1 minus, 2 minus, or 3 minus. Everything else is an anion. This is the only cation that's polyatomic. So in order to name polyatomic ion compounds. So our naming is very similar to before. You name the cation first. If it's multivalent, so that's into Ca8, so that's if it forms a different number of charges, so something like iron can form an iron 3 plus or an iron 2 plus. If it's multivalent, if your cation is multivalent, add Roman numerals for the ion charge. Again, if you don't know what that means, go to lesson Ca8. If it's not multivalent, there's no Roman numerals. To name the anion, we need to be careful. So if the anion is a polyatomic ion, so again, that's from the chart. The way that we name it is we name our cation first. So this one is Na, which is sodium. If it's polyatomic, all that you do is figure out what that ion is. So SO4 with a 2 minus we already figured out is sulfate. So if it's polyatomic, the big thing is you do not change the ending to IDE. You just write it as is. If the anion is a monoatomic ion, so something like chlorine or fluorine or oxygen or something like that, we name it the way we've seen it before. So that one is sodium. Chlorine is chloride. So in that case, we do change the ending to IDE. We wouldn't want to change this, just to show you what it is sodium. If we changed it to sulfide instead of sulfate, sodium sulfide is actually Na2S. The ending of IDE is indicating S with 2 minus, right? That's our sulfide ion. So we don't, can't cross it out enough, we don't change the ending to IDE if your anion is a polyatomic ion. So just a little bit more practicing naming there. So barium and NO3. So looking for NO3, we see it's NO3 with a 1 minus, which makes sense with barium because again, barium forms a 2 plus. NO3 forms a 1 minus, so we need 2 of those NO3s in order to balance the charge. So the way that we name this is barium. Barium is not multivalent. Barium can only form a 2 positive, so we would name that barium nitrate. This next one, copper, Cu, BO3. So we know it's going to be copper. Sorry, I'm trying to see. Gotta move my thing down. So BO3, is this the one that's not there? So BO3, so this is borate. It's BO3 with a 3 minus. And what it's telling us is we have one of these and we have 3 coppers. So the way that we know that we have 3 coppers is based on this little subscript there. So we have 3 negatives contributed by our borate ion. And so we know that we need to have 3 positives contributed by our cation. So we know that this needs to be copper 1 borate. So copper is an example of a multivalent ion. So we need to, in Roman numerals, indicate which charge is actually on our copper. This one, so our polyatomic is actually our first part. So that NH4 we already talked about. So the way we would name that is ammonium, and it's just one of our monoatomic ions, chlorine, changes to chloride. So ammonium chloride. We named our cation first. Our cation is our polyatomic. Next one, well, our cation is polyatomic, but our anion is also polyatomic. So this one, you just name your cation, name your polyatomic anion. So that one would be ammonium, and SO4, peeking in your chart, is sulfate. So ammonium sulfate is NH4. We'll talk about this whole situation when we're writing formulas, but naming our cation, NH4, SO4. So, on to what I was just saying. Writing the formulas. So it's really similar to what we've done up to these stages. So it says determine the charge of each ion. So whether they're positive or negative and how many positive or negative. The next one says balance the charges by adding subscripts. So just like other ionic compounds, remember to reduce the whole number ratio, sorry, the lowest whole number ratio if necessary, and treat your polyatomic ion as one unit. If you need more than one polyatomic ion, you must use brackets. Do not use brackets if you do not need them. So if you only have one of the polyatomic ion. So the first one, sorry, I'm going to do it down here because it's hard for me to write neatly. So calcium nitrate. So we know calcium. Looking in our periodic table, calcium forms a 2+. Nitrate. Nitrate is a polyatomic, so with that ending ATE, we know it's going to be a polyatomic, and it forms a 1-. So we know we have 2 positives contributed by the cation, 1 negative contributed by the anion. So now, we need to have more negatives contributed by our anions here. So the way that we would write this formula, again, we have 2 positive, 2 negative, we can now write it out. So we just needed 1 calcium. We don't write a subscript of 1 here. And now what we do, since we need more than one of our polyatomic, we put brackets. So CaNO3, and we actually needed 2 of those. So we needed 2 of that polyatomic ion, that nitrate ion. The reason that we put brackets around it is because we wouldn't be able to write CaNO3 2, because then that's saying we actually need 32 oxygens. So we put brackets around it. It's kind of like order of operations that it's saying that we need 2 of whatever is in that bracket. So that's why we have brackets around it. Tin 2 sulfate. So again, this 2 is telling us that it's tin with a 2 positive charge. It's not telling us that we need 2 tins within our formula unit. It's just telling us the charge on tin. So tin 2+, sulfate is SO4 with a 2-. So that's nice. It balances with the 1-to-1 ratio because 2 positives contributed by tin, 2 negatives contributed by sulfate. So SNSO4. So I'm not going to be as picky as it's saying here. If you put brackets around sulfate like this, it's not going to be the end of the world to me. In theory, it should just be SNSO4 instead of having brackets, but if you put them in just out of habit, it's not the end of the world. But missing brackets is absolutely a problem. So this is tin 2 sulfate, again balanced out. Sorry, ammonium sulfite. Hopefully you're seeing that one little spelling mistake can actually make a pretty big difference. So ite versus ate versus IDE, so sulfide. These all indicate very different things, so make sure you are spelling things right. So for ammonium, so ammonium again is NH4 with one positive. Sulfite is SO3 with a 2 minus, I believe. Sulfite, SO3 with a 2 minus. So we have one positive contributed by our cation, ammonium, two negative contributed by our SO3, that's our anion. So we know we need more positive charges. So now two positive, two negative. So writing the formula, ammonium, NH4. Since we need two of them, we definitely need brackets. So bracket 2. And then we just write our polyatomic anion, SO3. So you don't need to write brackets around it. Again, looking at all of these, you see that my formula never has charges represented in it. I just use my charges for figuring out what the formula would be. So make sure your formula at the end never has charges in it. So I think that is it for that lesson. So make sure you go to the CA9 worksheet and finish up whatever I've assigned from that and send it my direction, please. Thanks, guys.